The Atwood Machine, invented in 1784 by George Atwood to examine classical mechanics with constant acceleration. Essentially, a counterweight on a pulley can slow down the rate an object falls, allowing for more precise measurements. In these experiments, the counterweight weighs 332.4 grams. The magnets in attraction weigh 343.98 grams. The magnets in repulsion weigh 344.78 grams, and the non-magnet weighs 344.08 grams. For the magnets in attraction, the counterweight was placed at a height of approximately 90.4 centimeters. For the magnets in repulsion, the height is at 92 centimeters, and for the non-magnet, the height is at 91.4 centimeters. The magnets in attraction are on the left, the magnets in repulsion are in the center, and the non-magnet is on the right. The magnets in repulsion fell the slowest, and the non-magnet fell the fastest. The results of the experiments are shown. The magnets in repulsion fell at an average time of 4.033 seconds, which is 12.11% slower than the 3.597 seconds average drop time of the magnets in attraction. The non-magnets fell at 3.466 seconds on average, which is 3.64% faster than the magnets in attraction. Using basic calculus and assuming constant acceleration, we can obtain the equation for the acceleration of a falling object to be acceleration equals to 2 times the height divided by the time squared. The acceleration can also be obtained just by the masses in the Atwood machine and by applying Newton's second law, or F equals ma. Assuming a frictionless pulley, the tension on the string is the same on both sides, which can cancel out to obtain the acceleration to be equal to gravity times it by the mass 1 minus mass 2 divided by the mass 1 plus mass 2, where the first mass m1 is greater than the mass 2. The calculated acceleration rates and the expected Atwood machine acceleration rates are shown. The magnets in repulsion were expected to have the fastest acceleration rate at 0.179 meters per second squared, but this was off by 58.53%, as the actual acceleration was the slowest at 0.113 meters per second squared. The Atwood acceleration for the magnets in attraction was off by 20.21% and only 12.56% for the non-magnets. Additional information. My first attempt at gluing magnets in repulsion involved using shoe glue, but after clamping in a vice grip for 24 hours, the glue did not hold at all. I then used a metal epoxy glue and glued the two north poles together. After waiting 24 hours to cure, the metal epoxy glue barely held on to the magnets in repulsion. I was fortunate enough to film the Atwood machine experiment just before the magnets ripped apart only 20 minutes later. The magnetic viewing film was placed on top of the magnets. Note how the magnets in repulsion have two distinct Bloch walls or nodes. The magnetic field at the poles are also less spread out for the magnets in repulsion. I will try doing the Atwood machine experiments at a higher height, like my balcony, to confirm the results. Nonetheless, the results thus far appear to validate Boyd Bushman's claims that magnets in repulsion fall slower in gravity, as this previous replication attempt suggests it does.